Hi, my name is Suraj Dixit. I'm a junior in high school, and I was the recipient of the 2024 NAVS Humane Science Award at the International Science and Engineering Fair. My project's goals were to determine the feasibility of FDM 3D printing as an alternative to SLA 3D printing for fabricating lab-on-a-chip and organ-on-a-chip devices. So the thing with SLA 3D printing is that it's a resin-based, and that resin can contain cytotoxic chemicals that can pose a threat to the cells living in these devices. So on the other hand, FDM 3D printing technology, which is what I'm looking at, it's a much safer process that doesn't contain any of these chemicals. But the only trade-off is that FDM is much less accurate than SLA. So because of this, it can only create really rough hydrophobic surfaces which aren't suitable for cell growth and attachment. So my project looks at, okay, how can we take this FDM surface that's rough and hydrophobic and make it more suitable for cell growth by improving its hydrophilicity? And we're doing that by optimizing a wide variety of variables. So what I found was that through a rapid prototyping process, using polylactic acid polymer, PLA, instead of ABS, printing the surfaces vertically compared to other orientations, mechanically polishing the surface, and finally putting it through a hydrolysis treatment created optimal conditions for cell growth and attachment. I chose to explore this topic because of my background in 3D printing. I've actually been involved with 3D printing for around 5 or 6 years. I actually convinced my dad to buy me a printer when I was around 11 years old, and I've been constantly learning about it ever since. And when my mentor introduced me to its biological applications with like cell scaffolds and lab on a chip, I was immediately hooked, and that's kind of all I wanted to do. I think the reason that animal testing and in vivo testing is being used so much is because we can't lab test drugs that are going to eventually be used on living, breathing organisms. So what organ-on-a-chip technology allows us to do is test those same drugs on a very realistic replica of that organism's microenvironment, which would give us a much more accurate idea of how the drug would perform in a real situation. So through my project, we can potentially take these organ-on-a-chip devices and make them even better by reducing the toxicity of those microenvironments. I'm absolutely looking forward to continuing this research. I think the technology that I'm looking at is the future of drug testing, and I think we're really just scratching the surface here in terms of what we can do with these devices. I am planning to shift gears a little bit, and I'm going to try to optimize the actual FDM 3D printers themselves, because I do think there's a lot of room for improvement there to make them more accurate to eventually fabricate these devices. In terms of college, I'm planning on studying mechanical engineering, but this project has really sparked my interest in biology, so that could change. I would really like to go to the University of Michigan because they're a fantastic school for engineering. They also have a lot of great research opportunities, especially in what I'm interested in, which is microfluidics. If I had to give advice to a student looking to integrate humane methods into their science project, I would tell them to really think about what the goal of their project is. And if their work will be continued or built upon in the future, they should especially think about making their methods sustainable and humane. And I think one way to do that is to kind of change the way that you think and maybe broaden your worldview to see the humane implications of your project. And if you see a part of your project or a process you use that could be unethical or inhumane, you should take steps to change that. I just want to say I'm obviously very, very thankful to receive this award from NAVS, but I also just wanted to thank the people at NAVS for just dedicating their time to advance science without harming animals. I think we're already starting to see really promising alternatives to replace animal testing altogether, and it's definitely worth it to promote technologies like organ-on-a-chip to get them to that point. So, thank you.